All right, so imagine this, you are like fresh out of college, right?
Yeah.
You got that shiny new job in IT.
Yeah.
You're sitting there all excited at your desk, ready to, take on the world of tech.
The dream.
Exactly. The dream, right. And then bam, your first task, you need to open a file. Simple enough. But here's the thing.
Okay, I'm intrigued. What's the catch?
The file isn't on your computer. It's on the company's main server, right?
Yeah.
Like tucked away in some server room somewhere.
Makes sense, yeah. Standard practice, keeping things centralized.
Yeah, usually when your computer's talking to that server to get the file, it all happens within the office network.
Yeah, like a little closed network, right? Like an internal phone call.
Exactly, like an internal phone call. But what if that server isn't even in the office? What if it's living out there in the cloud? Like, say, Microsoft Azure.
Okay, now we're talking. Things are getting a little more complex.
Exactly. And that's what we're diving deep into today. How do you make sure that when your computer connects to this server in the cloud, it's secure? You don't want it just, shouting across the public internet for anyone to hear.
Right. You want that connection to be private, like a direct line. You don't want sensitive information just floating around out there for anyone to grab. That's a huge concern these days, especially with so many businesses moving their operations to the cloud.
Exactly. And luckily, Azure has some really cool tools to help us with this. For this deep dive, we're going to focus on one very important concept, something called private endpoints.
Private endpoints, yeah. They're like your secret weapon for making sure those connections are locked down tight.
Exactly. But sometimes, to really get how these things work, we need to look at other related concepts as well, just to get the bigger picture right.
Absolutely. Understanding the context is crucial. It's like, you can't just learn about a car engine without knowing a bit about how the whole car works.
Exactly. So we'll also touch upon something called service endpoints, just to see how they both fit in. It'll be like a quick crash course in secure networking in Azure.
And to help us out with this, we've got some awesome resources, right? We have that really helpful YouTube video by Mike in the Cloud and a super detailed article from Microsoft Learn on Azure Private Link. Those are some real gems for anyone wanting to dive deep into this stuff.
Yeah, Mike's video is a great visual guide. Yeah. And the Microsoft Learn article, it's like your ultimate reference manual. Together, they've given us a really solid understanding to explain things clearly to everyone today. So let's start by breaking down the problem a bit more. Imagine you have this Azure storage account, right? Think of it like a giant digital filing cabinet in the cloud.
The cloud filing cabinet.
Yeah.
Love that analogy. And inside you have, say, a picture of a beautiful Alfonso mango, just to make things more relatable.
Perfect. A juicy Alfonso mango, right? And you also have a virtual machine running in Azure. This virtual machine, it could be running some application that needs to access that mango picture.
Right, like maybe it's a website that displays different fruits and it needs to show that mango to the user.
Exactly. Now, if we don't do anything special, how does that virtual machine actually get to that mango picture in the storage account?
So by default, the first way the virtual machine will try to connect is over the public internet. It uses HTTPS, which is the standard way web browsers and servers talk to each other securely.
HTTPS, right? The secure stuff we see in our web addresses.
Exactly. So it's like sending a letter through the regular postal service. It goes out into the world and then finds its way to the destination.
And that's fine, right? I mean, especially if you need anyone anywhere in the world to see that delicious mango.
Yeah, if you want anyone who has the link to be able to access that mango picture, the public internet route is perfectly fine. But here's the thing. What if you want to be a bit more, shall we say, selective?
I see where you're going with this. What if we want to keep things exclusive, like a VIP club for our Azure resources?
Exactly. You don't want just anyone peeking at your mango. Or even more importantly, any sensitive company data that might be in that storage account. That public post office analogy, it starts feeling a bit too, open.
Right, like leaving your front door wide open. Not a good idea if you're storing valuable stuff. You want that internal company traffic to stay, internal. So what's the solution? How do we create that exclusive access?
That's where service endpoints come in. They are like our first step towards keeping things a bit more internal within Azure. Think of them like creating a special internal route within your network just for certain types of traffic.
Okay, so service endpoints, they help keep things within the boundaries of Azure, but they don't completely isolate the traffic.
Exactly. It's like marking a lane on a highway for specific vehicles. They still use the same road, but they have their designated path. Now, for Azure Storage specifically, when you enable a service endpoint on your virtual network, or VNet, you're essentially creating a direct internal path for traffic going from your VNet to Azure Storage.
VNet being our private network within Azure, right? Like our little Azure office building.
Precisely. So the traffic still looks like regular HTTPS. It's still using those same internet protocols, but it's being routed in a more controlled way, staying within the Azure ecosystem. It never has to leave the Azure network.
So even though it's using the internet language, the journey it takes is all within Azure's own secure network.
That's a great way to put it. Now, to get a little more technical, the service endpoint for Azure Storage, it's generally known as Microsoft.storage, or sometimes you'll see it as service.storage. And in the demo that we talked about earlier, Mike uses the term Microsoft.storage, but they all essentially refer to the same thing.
Okay, so if we enable this Microsoft.storage service endpoint on our virtual network, any traffic going from our virtual machines within that network trying to reach Azure storage, it gets automatically sent through this special Azure internal route. It's like having a VIP lane on the Azure highway exclusively for storage traffic within our network.
Exactly. It streamlines things, keeps things organized, and adds an extra layer of security by preventing that traffic from going out to the public internet unnecessarily.
Makes sense. So service endpoints help us manage internal traffic within Azure. But what if we want an even more direct and secure connection?
You're thinking about Azure Private Link and private endpoints now. This is where things get really interesting and we can create a truly isolated connection.
Right, because service endpoints, they're good, but it's still like using a shared lane, right?
Yeah.
What if we want our own dedicated private road just for us?
Exactly. Private link is like having your own exclusive tunnel directly to the service. No sharing, no detours. And here's how it works. Private link, it's actually configured on the Azure service itself. So in our Mango example, we'd set it up on the storage account where that delicious mango picture is stored.
Okay, so now we're not just tweaking the network, we're doing something directly to the storage account itself. That's pretty cool.
Absolutely. And here's a helpful analogy. Think of it like giving your storage account its own network card, a virtual network interface card, or NIC, right inside your VNet.
A virtual network card for our virtual Mango storage. That's a great way to visualize it. So it's like plugging it directly into our private Azure network, like adding another computer to our office network.
Exactly. Now, when you create a private endpoint for your storage account, you connect it to a specific part of your VNet called a subnet. And guess what? That storage account gets its own private IP address.
A private IP address, like the ones used inside our own network.
Exactly. And this is where the magic happens. Private IP addresses, they're only meant to be used within your own network. They're not directly reachable from the public internet. So that storage account, which maybe had a public address before, now has this private address that makes it look and act just like any other device inside your VNet.
So it's like we've brought that storage account, which was out there in the cloud, right into our own private Azure office space. It's now part of our inner circle.
Precisely. And this, my friend, is what makes private endpoints so powerful. Now, when your virtual machine wants to get to that Mango picture, it doesn't have to go out to the public internet and back into Azure. It uses that direct private connection, going straight to the storage account's private IP address. The entire journey happens within your own secure VNet, like taking that secret tunnel, no exposure to the outside world.
So much safer and more controlled. It's like having the dedicated private road that we were talking about. No traffic lights, no intersections, just a straight shot to the destination.
Yeah.
But here's a thought. Even with the private endpoint, does the storage account still have its original public endpoint as well?
That's a great question, and yes, you're right. Even though we've set up this private connection, the public endpoint might still be active. That means someone out there on the internet could still technically try to reach the storage account using its public address.
So we've built the secret tunnel, but the main door is still unlocked. That doesn't sound completely secure yet.
You're spot on. To really lock things down, we need to take one more step. We need to restrict public access to the storage account. We need to close and lock that main door.
Okay, how do we do that? How do we put up that no trespassing sign for the public internet?
Most Azure services, including storage accounts, have these really handy firewall or network settings. You can configure them to only allow traffic coming from specific sources.
So we can essentially tell the storage account, hey, only accept connections coming from our secret tunnel, the private endpoint, or from within our trusted VNet, our Azure office space.
Exactly. And by combining private endpoints, which give us that private connection, with these firewall rules that block public access, we create this super strong security setup. Our storage account becomes an exclusive club, only accessible to members, meaning resources, within our Azure environment, completely protected from the outside world.
It's like having a private party in our Azure mansion, and only those with special invitations can get in. Now, you mentioned Mike in the Cloud had a fantastic demo in his video showing all this in action. What were some of the key highlights that really helped us see how this works in real life?
Yeah, Mike's demo was a great way to see this all come together. He starts by setting up the basic Azure resources. First, he creates a resource group. Think of it like a folder where you keep all your related Azure stuff organized. Then he creates a virtual network, very cleverly named Storage VM Test, to keep things clear. And inside that VNet, he enables something called a Bastion server.
A Bastion server, right. That's like a secure gateway, right, to connect to our virtual machines without exposing them directly to the internet, like a secure entry point.
Exactly. It's like having a secure entrance to your Azure environment. Right. And then, of course, he creates the star of the show, the virtual machine itself, named Storage VM, and places it inside that Storage VM Test virtual network. That's our computer in the cloud, ready to access the storage account.
Okay, so we have our secure network, our cloud computer. What about our digital filing cabinet, the storage account itself?
Of course. Next up, he creates the storage account and calls it Storage Test Banana. Very descriptive. And he points out a very important detail. The name has to be unique across all of Azure. You can't have two storage accounts with the same name.
Makes sense. And for the demo, he chose a specific type of storage, right?
Yeah, he went with locally redundant storage, which is a cost-effective option, especially for testing and demonstrations. It ensures that your data is replicated within a single data center, providing a good balance of cost and reliability.
Okay, so network setup, cloud computer ready, storage space allocated, and now for the most important part, the data itself. Our precious mango picture.
Right. He uploads a picture of a banana named banana.png into a container within the storage account. He named the container Fruit. Very fitting. Initially, to show how things work by default, he makes this container publicly accessible.
Publicly accessible, so anyone with a link can see the banana at this point.
Exactly. And he even shows us what that public URL looks like. It's something like storagetestbanana.blob.windows.net fruitbanana.png. This is the standard way to access files in a publicly accessible Azure storage container.
Right, so the banana's out in the open, anyone can see it.
Yeah.
Now, how does he start to lock it down using those service endpoints we were talking about?
He goes into the settings of this Storage VM Test virtual network, the one we created earlier, and adds the Microsoft.Storage service endpoint to the default subnet of that VNet. This is where he creates that special internal Azure path for traffic going to storage from this specific network. Remember those dedicated lanes on the Azure highway? That's what he's doing here.
Right, so he's making sure that traffic originating from his VNet, specifically destined for Azure storage, stays within the Azure network, doesn't have to venture out to the public internet. It's a good first step towards better security and control.
Absolutely. But as we discussed, service endpoints are just the beginning. The real isolation comes with private endpoints. So what does Mike do next? He heads over to the Storage Test Banana storage account and navigates to the section for private endpoint connections.
Makes sense. He's going to create that private exclusive connection now.
Exactly. He creates a new private endpoint and names it Storage Private Endpoint, again, keeping things clear and easy to follow. He specifies that this endpoint is for the blob part of the Storage Test Banana storage account, which is where our banana picture is stored. And very importantly, he connects this private endpoint to the same default subnet within the Storage VM Test virtual network, where his virtual machine storage VM is located.
Connecting it to the same subnet. That's where the storage account gets its own private IP address within our network, right? Like getting its own internal phone extension.
Exactly. And as soon as the private endpoint is created, the storage account gets assigned a private IP address from the range of IPs used by that subnet. It's now officially part of the internal network family. And another cool thing that happens automatically is that Azure creates a private link, private DNS zone.
Private DNS zone, DNS being the domain name system, right? It's like the phone book of the internet.
Yeah.
Translating human readable names into those numerical IP addresses.
Exactly. And normally the public DNS would translate the storage account name to its public IP address. But now within our virtual network where this private endpoint exists, this private DNS zone takes over. It makes sure that when someone within the VNet tries to access the storage account using its regular name, it gets directed to the private IP address of the private endpoint instead of the public one.
That's clever.
Yeah.
So from within the VNet, even if you use the storage account's public sounding name, you're actually getting routed internally through the private endpoint. It's like having two different addresses for the same place, one public and one private, depending on where you're coming from.
Exactly. And it keeps things simple for the users. They don't have to remember different addresses. The system handles the routing seamlessly behind the scenes. Now, to test this out, Mike tries to access the banana image from within the storage VM. What happens?
I'm guessing, even though the private endpoint is there, he can still access the banana via the same public web address.
You got it. That's because the public endpoint is still technically active. But here's the cool part. When he uses the nslookup command from inside the VM, just on the storage account name, without the full web address, it resolves to a private IP address.
The nslookup command, it's like looking up a number in the phone book, right?
Uh-huh.
And it shows that the storage account is now associated with a private IP address, something like 10.0.55. So even though he's using the same name, the traffic is actually being routed internally through the private endpoint.
Exactly. That's confirmation that the private connection is working. But just to highlight the difference, he then performs the same slookup command from his own computer, which is outside of Azure, on the public internet. And what does he see?
I bet it still resolves to the public IP address of the storage account, showing that from the outside world, it's still accessible via the public endpoint. So we have this internal private connection, but the public door is still technically open.
Exactly. And this leads us to the final crucial step in the demo. Mike wants to lock down the storage account completely, make it truly private. So how does he do it? He goes into the networking settings of the storage test banana storage account and changes the network access from enabled from all networks to enabled from selected virtual networks and IP addresses.
So he's basically saying, hey, storage account, you're only allowed to accept connections from a select few, no more open door policy.
Exactly. And guess what he adds to that list of allowed networks? The storage VM test virtual network, the one where his VM is located. It's like giving out exclusive VIP passes to only the people in your trusted circle.
Now, what happens when he tries to access the banana image again?
From inside the storage VM, which is part of the allowed network, everything works perfectly. He can still access the banana using the same web address because the traffic is flowing through the private endpoint. It's like using that VIP lane on the highway, smooth sailing. But when he tries to access the same image from his own computer outside of Azure, he gets denied. Access denied.
The storage account is now a fortress protected from the outside world. It's only accessible from within that specific VNet through the private endpoint. So, to wrap things up, what are the big takeaways for our listeners, especially those who are new to Azure and cloud networking?
The key thing to remember is that private endpoints provide a secure and private connection to Azure services from within your virtual network without exposing your traffic to the public internet. They essentially bring the service inside your VNet by giving it a private IP address.
It's like building that secret tunnel directly to the service, ensuring that all communication stays within your own secure network space.
And combining private endpoints with those network security rules that restrict public access, that's your winning combination for creating a robust security posture for your Azure resources.
It's like having a security guard at the entrance of your tunnel, making sure only authorized personnel can enter. Now, it's also important to remember the difference between service endpoints and private endpoints. Service endpoints are like those designated lanes on the Azure highway, keeping traffic within the Azure network. But they don't provide a private IP address for the service within your VNet in the same way that private endpoints do.
Exactly. Service endpoints are good for controlling traffic flow within Azure, but private endpoints offer a much higher level of isolation and security, bringing the service directly into your private network space.
So service endpoints are good for general traffic management, while private endpoints are your go-to solution when you need that extra level of security and control, keeping those Azure services truly private.
And remember, this concept of private endpoints is applicable to many different Azure services, not just storage accounts. The Microsoft Learn article we mentioned has a whole list: Azure Cosmos DB, Azure SQL Database, and many more.
It's a versatile tool that can be used to create secure connections for various parts of your Azure environment. So as you continue learning and exploring Azure, remember the power of private endpoints. They're your key to building truly secure and isolated applications in the cloud.
Absolutely. And this is just the tip of the iceberg when it comes to Azure's networking capabilities. There's a whole world of tools and features to explore. So keep learning, keep experimenting, and see what amazing things you can build.
Couldn't have said it better myself.
Cheers to that.
All right, that's a wrap for today's deep dive.
Until next time.
See y'all soon.